Hello everyone, today I'm going to show you with this tutorial a few effects with TyFlow and Redshift, some motion graphic effects. As you can see here at the finished scene, it looks pretty nice. It's rendered pretty fast as Redshift is a very powerful render engine. And yeah, let's get started. First of all, I would say to achieve this effect you need TyFlow, Redshift, 3ds Max of course, and later in part 2 you need Stoke, which is free of course, so don't worry about that. Okay, let's start. I will maximize this viewport and click Alt W, and and I will import some symbols that I just created with Adobe Illustrator. Some of them with the new generative AI feature, which is pretty cool, but I won't show that today. You will find some other tutorials on that. It's very cool, but let's get started. Okay, and here they are. Just a few simple symbols like a heart, plus, a ring, smiley. Yep, you can see better. A star and a gear, and I will show you how I extrude them. I will just take the extrude modifier, disable the cap start and cap end. Then I will choose the edit poly modifier, use the border method and select the borders here from the outside and the inside. Go back into extrude, enable cap start and cap end, and then here, still selected the borders, I will create the chamfer, not with this value of course, but a value like 0.04 I would say, and of course a few more segments like maybe 6 or 5. Okay, I think this looks fine, and let's check the check mark to apply the chamfer. Okay, I will do this on the other symbols off screen, and I will be right back. Okay, and here we are. They will be our particles. But before we start with our TyFlow, I would like to create the symbol, in this case my JFArts symbol, which will be the hero in the simulation. Okay, here it is. I will just move it up and rotate it around the x-axis about 90 degrees, of course. Extrude it. Maybe a little more. Okay. Now, well, I would like the particles to be a stream. I'll just make it a bit smaller so that it has a width of 2 units, I would say. Okay, first of all, before we go over to create our helper objects for the TyFlow, I will just go into Customize, Unit Setup, and check the system units, which is inches, and generic units as displayed units. Okay. Also, I will change the timeline to a range from 0 to 400. Okay, now before we start with the TyFlow, I would like to paint a line. The line will of course be the line where our emitter will move along and emit some particles. Okay, so let's go here on the spline section and click on line, and then we create something like this. Well, at the beginning, of course, the default state is that new lines will of course be placed on the floor, but we will change that. First of all, I would just like to make this line with a 270 degree rotation around my symbol, something like this, and then we will end just here. Plan for later is that the camera will be somewhere around here, so the particles, after they flew around the symbol, they will just stop here somewhere in the air and be around the camera. Okay, yeah, this is almost good, I would say. Well, of course, we will change something of this, make it a little bit rounder. Yeah, something like this. Let it move around the symbol a bit closer. Maybe we can delete that and put this somewhere here. Okay, now I will change the heights of the vertices, and yeah, how about if I just let the line walk through my symbol? That would be good, or just how I imagined it. And over here, just a little bit above the symbol as well. But that's just my taste. Of course, if you do the same with your symbols or objects or whatever, do whatever you want. It will also work with the flow that we will create in just a second. Okay, yeah, and then I will let the particles rise at the end, something like this. And yeah, and at the beginning they will also be a little bit above the ground, maybe higher than the further vertices. Okay, I think this is good. Yeah, we can go on with this. Okay, next we will create the sphere. The sphere that will be our emitter, something like this. It doesn't need to be so large. This is already good enough, I would say. A radius of 0.6. Yep. Okay, and then go to animation, constraints, and path constraint. And then we choose the path that the sphere will be constrained to, and this is of course our line that we just drew. And yeah, it already works, but I would like the sphere to move faster. So the last keyframe, which will be the section on the path that our sphere is following, will be at frame 300. And also later we will emit particles not just until the end, but rather here, when the sphere is here, so at about frame 240 or 50. Yeah, then it would be time to create our TyFlow simulation. Okay, go here, create the TyFlow somewhere in space, and go right into it. Okay, it all starts with the birth event, and this will of course emit particles from frame 0 to frame 250, I would say. Okay, the frame number is okay by now, but we will increase it later. So just leave it as it is currently, and then we choose our position object. And this will be, of course, our sphere that we just created. And we emit from inside of it, so we choose volume as location. And then afterwards, we choose under the motion tab, inherit object motion. Okay, everything else leaves as it is, at its default states. Okay, then we choose our shapes. And they will be, of course, our symbols that we already created. Add selected, remove the triangle, which is the default shape. Oh, I will just rename the hertz into heart, just to stay in English. And then we switch our display mode to geometry. Let's take a look. Okay, not so nice, but there are still a few things we need to change. Go back into TyFlow, add a scale operator, and then choose in the scale value a value of 0, go up to frame 6, I would say. Press the auto button to create keyframes if you change any parameters. And so we go here and change the X value up to 10. Okay, that's it for the keyframes. Press uniform at scale variation, because we want to have some variation, of course, and then type in something like 60%. Go back and watch. Of course, the keyframes will be synchronized to the particle age, and the timing will be on continuous. Okay, and then we need to change the mode into absolute, and now we should see something. Okay, still not as supposed to be, but with a slow operator we can slow them down with a value of 11% at each axis and a variation of 9%. And also the spinning will change here, but we first need a spin. And we increase this up to a spin rate of 200 and a variation of 50. So this will look much better. Okay, well, I would like to give the particles a little bit of speed and turbulence at their birth time. So it will not only be just a line that is drawn here, but it will also be a bit more spread. So I will give it a speed operator with a tiny magnitude of 0.33 and a variation of 40 with the random 3D direction. Much better. But also with a recognizable pattern of turbulence, and this will be caused also by a force operator which operates only at the beginning. So change on the timing, the settings to on event entry. So there you can go and choose a very high value at the strength, which will be 17, and the turbulence will have a scale of 22. Okay, that's it. That's the entire change, and let's take a look. Okay, that was too much. Maybe a value of 1.7. Okay, now here comes the thing. I would like the particles which are a bit closer to our symbol change to another event, and we can achieve this by using the surface test operator. So the surface test operator takes the geometry, in this case our shape or our symbol, then it tests the particles to be in a distance less than a value of choice from the closest point on the surface of the shape. So here I would pick a value of maybe 8. I will change the color here, of course, so I can see the effects. Yeah, it works, but there are still some mistakes in it, because some particles will fulfill this condition at the very beginning of their birth, when the sphere is very close here. So they still need to have their scale to be changed over lifetime, so that's why I picked particle age as keyframe synchronization mode. And also I will change these operators because I also need them in this event. So I will change the timing also in particle age, so they will operate at the birth of a particle. Okay, so I copy them over to this event. Just to make sure that the particles will behave like they were emitted here and continue their behavior in the new event. If they are born here and switch over after a couple of frames, or if they are born here and immediately change over at the age of 0 frames. Okay, and last but not least, I will also copy the slow operator. Alright, and let's look at this. Okay, it works. And you see by the color of the particles, they are in these two different events. Okay, but something should happen here. So I would like the particles to slow down and start moving around the object and get closer to the surface. And this will be done by scripting. So we use the script operator right now. Here it is. Okay, let's go into it. I like to delete all the comments which are in the script operator by default. When I start to script something, I will delete everything in here except the for loop, which is essential for changing the particle's behavior. Okay, let's go. First of all, I would like to create a vector that has the position of the particle to make it easier later in other functions. So I will get the particle's position channel and move it into the pos vector. Also, I would like to have access to an object, which is of course our symbol. So I go back in TyFlow and then pick as a script accessible object the shape, and then I would like to get into another vector the closest point, which is CL point in my case, and this can be accessed by obj001 and the function get closest point seen from, of course, particle's position or pos. Okay, next would be the distance to the closest point. So I create a float and just call it distance, and this will be 0.3 distance pos. Okay, but here I would also like to add something, so I will subtract a float or a global float that I can access from here. So the first float will be called stopping distance and the other one will be called scalar. Okay. The stopping distance, which will be called in here, so that the distance value will already show 0 if a particle's position is not entirely on the surface. And this will be divided by a scale factor, which we just created, and its name was scalar. Okay, and also I want to cut off these values so that I won't get negative values, so a value between 0 and, of course, a value of 1 for some sine functions later. These arguments, the calculation, the minimum value, and the maximum value, are the arguments for the C# function for floats, which clamp values. Okay, evaluate. Okay, but we are not done yet. I would like to have a vector that I will use as a force that pulls particles towards the center of the shape or the icon, and so we'll call it pull, and it will operate the object's position minus the position of the particles. And of course, we will normalize this vector. Another important thing for a vortex that we want to create is that we have a second vector that is continuously showing up, and this will be called up, and its values, or its component values, will be 0, 0, 1, of course. We don't need to normalize this because the length, of course, is already 1. So now we can create our vortex, which is orbiting around the object, and this vortex will be created by a simple vector cross function using both vectors pull and up. Last but not least, I would like to add a little tiny turbulence in it. So I will also create a vector which is called just tur or tour. And this will be created by the TyFlow function for get turbulence. The value for the argument of time will simply be the time itself. So t, the position for the turbulence field will of course be the current particle position. The frequency will be 0, and the scale for the turbulence will also be a global float. The linearity will be 0, the value for octaves will be 1, and the float will be 0 as well. Okay, and let's take a little look. What would happen if I just set the particle's velocity with our vectors, the pull vector, as well as the vortex vector and the turbulence vector. Evaluate. I need to write it correctly, and also I need to create the turbulence scale value. And this should be 0.2. The scalar in this case will be 20, and the stopping distance will be 1. And now we definitely will take a look at it. Okay, that's not how we expected. First off, I would like to create custom properties before the Scriptoperator so that I can transfer the velocity into a custom vector channel. Okay, and we'll just take a look at this, how this would end up if I just use this. Okay, that's correct, but there's no slow operating. No, there's no slow function operating, of course. But we can do this into our script, and therefore I will create a float which will be called hRamp. I will immediately create a clamp function in this case, and then I would take the particle's event age, get event age from the particle, and I will divide it by 25. Use 0 as the minimum value and 1 as the maximum value. Yeah, maybe it would be better if I would just subtract from the event age value of 5. Use brackets, of course. So this will operate first. So the decline would just start after 5 frames. Because then it will rise, and at the age of 30 frames, this will be 25 divided by 25, and it will end up into the value of 1. Okay, so let's test this. Multiply this by 1 minus h ramp. Okay, it works. And let's take a look if this will slow down. Okay, that's nice, but I still want to change something of it. And this will be a sine function. So these are currently values that will rise from 0 to 1 over a lifetime of 5 frames to 30 frames, of course. And the value 0 of 1 can be easily multiplied with pi. And as we know from sine functions, pi times 0 equals 0 and pi times 1 equals 0 as well. So we need to multiply this in between with a value of 0.5 and then use the sine function for all of this. The reason why I use the sine function is because now the values, of course, will start from 0 and end at 1, but they will also no longer be linear rising. And this cubic interpolation is what I wanted for this. Now let's take a look at it. Okay, it looks a little bit smoother, but that's exactly what I wanted. And now that we have this, we can go over and include our vectors pull, vortex, and turbulence. So we add them on top. And of course, we will multiply it by the h ramp. But this time h ramp isn't reversed. So we have something like a crossfade between the decline of this vector, this inherited velocity vector, and the new vectors that we created. But we also need to mix them up a little bit. So I would like them to be so strong in their pull behavior. So I will just multiply it with a value of 0.13. The vortex shouldn't be so strong as well, but a little bit stronger. So I will multiply it with a value of 0.4. And the turbulence will also be very slightly with a value of 0.15, I would say. Okay, and last but not least, I will multiply this by our distance float. Okay, let's take a look again. Maybe the scalar of the distance float can be bigger, so maybe 50 would be a good value. And also I would like the particles to stop at some point, and then I will create another h ramp, and therefore I will simply duplicate the first h ramp, but we call it h ramp master. We can already reverse it, but we change the values a little bit. So the decline will start a little bit later, maybe 100 frames of the event 8 later, and then it will take 100 frames to rise up to a value of 1. So after this whole calculation, the reversing, we'll have a factor of 0, and this will be our last multiplier. So the particles will stop at some point. Okay, let's take a look. Yeah, they will stop here. Okay, for my taste, the pull force can be stronger, maybe twice as much or almost twice as much. The vortex also can be a little bit stronger, so I will take a factor of 0.6. And turbulence, Yeah, okay, this can also be twice as much, so a value of 0.3. Okay, that's nice. Okay, let's move on. I would just decrease this slowing value. And also for our simulation, I will make these particles be physically accurate. So I will use a PhysX shape operator and put it here. The mode is set to convex hull and all these other conditions except this here, the stud penetrations, because they are born very close to each other. This will also be correct right now. And right here, when they are very close to the shape, they can collide with the shape. So I will take the PhysX collision operator, put it in here, change over to the mesh hull type, and of course I will choose the shape. Yeah, I mean my icon or symbol. And then I would like to take a look at this. Okay, it doesn't work as it should. But the reason for this is that the default settings in PhysX in TyFlow are that there's gravity enabled, but we don't need that. We only need the particles to be able to collide with each other, with our symbol, and of course with the ground. And that's just what happens right here. Okay. Before we take a first look into the render, we first need to switch from Arnold to Redshift, of course. And we need to add mesh operators to make it visible for Redshift. Okay. And here as well. And now I would like to add a new section or a new layer, which is called render objects. And right here I will create a plane for our floor. And this will have maybe 60 or let's say 99 length segments. And of course, this will also have a bend operator with the angle of 90, direction of 90, and limit effect. And yeah, maybe this will end somewhere here. Okay, let's rotate it a little bit. Maybe make it a bit wider, as well as here. So it has something like 250 times 250 units in its dimensions. And then I will put it here, somewhere behind it. So the camera will have a nice background. Something like this should be good enough. Okay, and let's go into the material settings. Okay, the foundation of everything will be Redshift standard materials. So here our floor, our icon, and our particles will all have Redshift standard materials, but with some changes. Okay, let's first start with the floor. I would like the floor to be a little bit blue, something like this, but a bit darker, like this. Okay. Okay, that's it. And now let's get over to the material for the icon. And this will have a rougher reflection value of 0.6 and less in its weight. And of course the subsurface will also have an effect on this. This will rather be a bit bit more bluish or a bit more like purple. Yeah, something like this. Okay. And also for radius, I would like to have pink. Okay, that's good, I would say. And very important, the scale will be decreased to a value of 0.3. And now, last but not least, we go over to the particles material, and that will have also a roughness value of 0.6 and a weight of 0.7. And subsurface, they all will have the same bluish color, like this. And because they are so tiny, they will have a very, very low value in the scale of the subsurface radius, but the radius will have varying colors. And how do we do that? Of course, we go to the maps and take a vertex color, map into it, and put in here. Okay. We will change it to a map channel of, let's say, 10. And in TyFlow, the particles will have, at their birth time, in their particle mapping channel of 10, varying colors. Like this as the foundation, but of course with variation in the hue. Okay, then we will just apply the materials on the objects. We will apply our particle material onto our TyFlow object. Our floor material will be on our plane object in the render objects. And our icon, of course, will have our icon material. So select shape and then apply this onto it. Okay, now we take a look. We make a first render in Redshift. But before we do that, first need to add a light, create a Redshift physical light, make it targeted, change the light to our disk, uncheck the visible tab, and move it up a little bit, or move it away first and then move it up, something like that, or maybe a little bit more from here. And the target should be on the 0 coordinate, and then go here somewhere. Okay, press Ctrl C to create a camera from your current view. Go out of the camera. Yeah, the target distance is okay by now, I would say. Yeah, somewhere like here. Enable depth of field. That's a good reference, I would say. So for the camera, we will add a Redshift camera attributes modifier, and this will have an aperture of maybe 1.3 or 1.5, I would say. Okay, go back into the camera, and then we will take a first look. Okay, my bad. We still need to create dome light with an intensity of, I would say, 0.3. Oh, I guess I missed something. Of course, the weight of the subsurface section must be at 1 on material object and the icon object as well. Okay, and then I would like to change the resolution up to full HD and take another look. Okay, that's very nice. I still need to make the sphere invisible, of course. And also I would like to add some motion blur. So go here in the render settings, press advanced, and then go into the motion blur tab, enable. Maybe we'll take 3 steps. the formation blur will also be enabled, and let's switch again. Oh, before I forget, to make motion blur visible, go in TyFlow in the Interfaces tab and enable particle interface. Okay, now we can take a look at a preview of the motion blur and the depth of field, but they also need the bokeh enabled to make blur visible. Yeah, that should be it. Maybe we will go to another frame, get closer with the camera as well. Maybe something like this. Okay, I think this looks good with the depth of field. Well, I will also change something with the particle count, or maybe we'll just need to check if everything's correct with the motion blur. Okay, you see some motion blur. But yeah, that's okay. If the motion blur is not so high, or then you recognize the nice shapes of the particles a little bit better. But it all depends on your choice. Just play with the global value here in the shadow section. Yeah, maybe 30 is also nice. So I will increase the particle count, and then I will be right back to show you how it looks with maybe, let's say, 1200 particles. And also I will emit them until maybe frame 280. Okay, I found my final settings, and this would be in the particle material. I changed the scale for the radius up to 0.06, and here in the global motion blur value, I changed it up to 22, and my aperture is also at 3.5. Also, I decreased the Redshift dome light down to a value of 0.15, and the physical light from Redshift to an intensity of 150 instead of 100. Also, I changed the position a little bit to something like a 90-degree angle. And also for the camera, I put a slightly animation from down to top. Okay, that's it. For now, I will let this render. And for part 2, I will show you how to let this icon appear with the help of Stoke and Field Magma. So be excited for part 2, and thank you for watching, and bye bye.